Today I will be showing you the Lewis dot structure of a covalent molecule and polyatomic covalent ion. We will start with the covalent molecule, the simpler of the two. Before we do anything, we have to determine the number of valence electrons which make up the outer shell of each atom. Each of the two silicon atoms has 4 valence electrons, giving them a total of 8. Each of the two fluorine atoms has 7 valence electrons, giving them a total of 14. Each of the two hydrogen atoms only has 1 valence electron, giving them a total of 2. This gives us a total of 24 valence electrons. I'm just color-coding this to make it easier to see what's going on. Anyway, described by the rule of octet, each of these atoms desires to have their outer shell filled with 8 electrons. This rule does not apply to hydrogen, however, which only desires 2 electrons in its outer shell. First, you take the atoms with the most unpaired electrons, which in this case would be silicon, and pair them together. In this case, silicon is double bonded with itself, and it will become apparent later why this is preferable. The unpaired electron in each fluorine's outer shell is completed with one of silicon's unpaired electrons. To complete the outer shell of hydrogen and have it contain 2 valence electrons, its unpaired electron is bonded with silicon's last unpaired electron. Now the outer shell of each atom is filled. Each of the silicon atoms and fluorine atoms have 8 valence electrons, and hydrogen has 2. To make the Lewis dot structure complete, the shared pairs of electrons have to be replaced with lines that represent the bonds. The last thing to do is add brackets around the entire structure and you are finished. Now for the more complicated of the two, the polyatomic covalent ion. Before we do anything, we first have to determine the number of valence electrons. The first atom we are dealing with is manganese. In this case, we will consider valence electrons as the electrons that participate in chemical reactions. Taking this definition into consideration, in the permanganate ion, manganese has 7 valence electrons, 2 from the s orbital and 5 from the d orbital. Each atom of oxygen has 6 valence electrons. 6 electrons from each of the 4 oxygen atoms added to the 7 from the manganese makes a total of 31 valence electrons. Because of the -1 charge, there will be an added electron which will bring the total up to 32. Oxygen is bonded to manganese with a single bond, filling oxygen's outer shell up to 7 valence electrons. To make this atom of oxygen's outer shell contain 8 electrons, we have to add 1, which creates the added charge of -1. Then another oxygen atom is added to each of the other sides of the manganese, but instead of being bonded with a single pair of electrons, it is double bonded. This makes the outer shell of each of these oxygens completely filled up without needing any extra electrons to complete them. Each of the valence electrons that makes up a bond is replaced with a line in the diagram. You put your diagram in brackets with the charge at the top right. That is your finished valence notation.